I'm asking this if this kind of installation is made only in the city, or can do in everywhere.
Yeah, most of the cases I saw till now were in cities. Of course, if there is some network that goes far for some point to treat the sewer content, and sometimes it happens because you can have a network that collects the sewers in the city, but goes someplace not so near the downtown to have the appropriate treatment to this material. Could be a possibility, but most of the cases I saw were in downtown place, in very crowded place, in old towns. It's most. Of course, things start to happen when you have a new. It's another way to see this possibility is thinking in partnerships. Then, if someone intend to build a new neighborhood, they can put some facility, and could be, depends on the interest of both companies, could be done since the beginning. But most of the time, this is applied in old sewers network just to avoid a bigger problem that could happen if we use another conventional way to install the fiber. It's more common to have this. The next topic refers to Marineised and submarine optical cable. I2 has some definition, and the classification that's used in this handbook refers to the same classification that is used in a handbook specifically about this subject. Anyone interested in this subject could consult the handbook that is named here. It's I2 Handbook on Marionized Terrestrial Cable, and was especially developed for Marionized cable, because there are some countries that use it a lot. Then part of the information could be useful to one interested in Marineised and submarine optical cable. And there are three kinds of optical fiber cables. The first one is called Marineized terrestrial cable. It's a kind of cable that's generally used for crossing lake and rivers. Why is the reference to marine and terrestrial? The second one is repeaterless submarine cable that use both in shallow and deep waters, since the length is less than 300 kilometers. And as we have a relatively short length, we can use this without any repeaters in the way the cable is installed. The more general use of submarine cable is long distance. Then this is repeated submarine cable. This cable is used in underwater application, mainly for deep waters on land that requires the deployment of submerged repeaters. Then there is a lot of information on, especially on internet, and relate to the company that deals with kind of cable. We have a global network of cable interligating all the continents, and there is a lot of cable planning to be installed in the future. Most of these cable are this kind. It's a very specific kind of application. Then there is a lot of consideration that needs to be taken into account. The first one refers to the survey and the route planning. There is a lot of points that needs to be established. And several months ago, I was in one of the bigger manufacturers of this kind of submarine, and they have a book that lists the history, not optical fiber, but the old cable, the old metallic cable. It was surprised when I discovered that the first, the second, and the third system that was planning to work between United States and Europe, they didn't work. They spent a lot of money, put the cable, and the cable didn't work because of different reasons. And every time the people discover what could be do better in the other time, most of the time the people lost the money, 2 times closed the company. And it's funny, we look now, we have a lot of cables around the world. Some cables has length of 4,000 kilometers or more. And it's nice to see that 100 years ago, people start to think could be pass a cable for such a long distance, and it could work. Then, in this way, the first thing that's necessary to know is to know a lot about the route, and there are a lot of mechanisms to be used. This survey and route planning has 3 phases. The first one is what we call desk route study. The second one is a route survey, and the third one is a route planning. The idea is to get all the information and sit down at the table and know a lot, and after that, go to the field and confirm or know more. Of course, to go to the field, you need to have some route in mind. But the final planning of the route is the third part, and considering all this information. And imagine you have to put the cable at sea level. Normally, it's easy to reach to 2,000 meters of deep and different kind of structure. And the information necessary for this is very important. Going into detail in each one of these phases, the purpose of the desk route study is to assess the factor affecting the selection of a marinized or a submarine cable route between the terminal station. Then we have 2 points to be connected. It's necessary to investigate a lot of things. The first is land routes and landfalls, study nautical charts, know about the tide and sea currents, know about wrecks, other underwater cables or pipeline that are already installed near the way they intend to put the route, know about the fault history of this infrastructure, because what affects the existing could affect the new one. Know about the shipping activity in this area. Ship used to use anchor. Anchor going down over a cable could be a disaster, or just having the cable in the anchor and trying to put up the anchor could be another kind of disaster. Some positions, some parts of the ocean or rivers, lake is not so frequent, but could have some navigation restriction or military restriction. Then it's necessary to know what these could be in the area. Because if we have a military exercise, could affect the cable. Some exercises are done in the water. And also, it's very important to obtain the cooperation of authority in other parts that are interested in this, in defense, in port, in marine area, in public works, and other cable works. And there are a lot of things that we are not going here in deep detail, but when it has some expensive operation like that, how many partners we have to put the cable, cheaper will be the part of everyone. And it includes, for example, the use of the same ship to lay down different cables and split the cost associated to this. In a way ahead, it's necessary to get permission. Then it's necessary to know about these authorities, because sometimes we are crossing some areas that belongs to other country. Imagine you are in area like a Caribbean area, intend to send a cable, to lay down a cable to other place. It's usually to pass in areas of other country, and the country needs to allow this. Then it will be very expensive to go to the high sea and come back to the point. Then sometimes this country, this other country are involved with the same cables, sometimes not. It's necessary to consider all the permission. Also, fishing activities are very important. We don't know a lot what happened in ocean, then it's necessary to know about fishing activity. In particular, where there is trawl nets and other fishing devices that could represent a risk for the integrity of the cable. Like the other cables, the idea is to keep this cable in position for 20, 25 years or more. It's necessary to know this. And all these items are investigated in the first study, this desk route study. In case of international submarine links, also it's necessary to identify if there is some issue related to political, economic, or practical aspects that could affect the landing points if they are connecting different countries. There are a lot of regulation related to a lot of aspects affected by this case, some related to the passage of the cable, another related to the obligation to use labors of the country to do some work. There are some special obligation related to equipment that are installed in each country, because if you need to stop and have a landing point in some country, it will be necessary to put equipment. The equipment will be related to some companies, and there's a lot of details to be considered. Considering all this information, when they are put together, it results in a tentative route which can be further investigated depends on the characteristics of the link. This further investigation is called route survey. It normally refers to the physical aspect and could involve a small boat or a special survey ship. Again, it depends the characteristic of the link and, of course, the characteristic of the way this we intend to use in this link. The second step is the route survey. This route survey is performed before the cable laying, and the idea, the intention is to select the cable route and the means of protection of the cable. This submarine cable generally has 3 or 4 different sections considering the construction of the cable. Normally, we have the fibers inside a duct, and the first polyethylene protection layer. And after that, the manufacturer apply more and more armor, more need the protection. Then in deep sea, the cable is almost just the polyethylene part protection. More near the shore, more could be affected by ships and fishing activity, and so it's necessary to protect more the cable. Of course, this polyethylene or similar material layer is intended to support all the pressure associated of the sea at that deep. Then to establish what part of the cable will be protected in one of this way, it's necessary to study the sea depth profile, the sea bottom temperature, and the seasonal variation. It's important also to know the morphology and nature of the sea bottom, to consider the position of existing cables and pipe, consider the cable fault history, the fishing and mining activity. It's usually more and more to trying to get petroleum from the sea. And then it's important to know what is here, is there in any place. And after that, to give the information to the people that will use the area in the future, to consider the cable that are laid down in this point. Also, it's necessary to see what is the sea current in all the way, all the path the cable will be, and also the seismic activity. Some countries recently are increasing the territorial part of the sea. One ONU new resolution in the past established that each country could put under his protection 200 miles or up to 250 miles. And imagine the people planning some of these paths in 250 miles from some country, and the country change his territorial autonomy. Then the first moment, the people don't need to ask permission to put the cable there, and after this, the people need to ask for permission. I'm saying that because two countries did that decision the last month. Two countries changed from 200 to 350 miles. Sometimes a comprehensive desk student has enough information, and the route survey could not be necessary. Imagine a lake crossing. The company is putting the second cable in that crossing. And the cable has a lot of information. It's not necessary to go and see. If there's some specific point to be considered, the experience will indicate and look at that specific point. The general idea is more you know, less you need. Then the first is always important. The second one could be important one case another. Another important thing related to the route survey is use of GPS with differential GPS. And typically, the accuracy of this system is 5 meters. That's fantastic to establish the route and also to see the level, sea level, or what is the situation. The Batmatic Investigation is a kind of measure of the sea level and is normally carried out using echo sounder that will follow the planet route and know more about especially the steep slopes or very rugged seabed. The idea is that when you have steady position, the cable is under certain kind of tension. When you have deep, especially the slope is high, it's necessary to consider some aspects related to the cable project, but it's also necessary to consider some aspect related to maintenance. If in this kind of cable, if it's necessary to be a repair, the repair will include find the cable in the bottom of the sea, bring the cable to the surface, do the repair, and put the cable again. And it's involve a lot of force associated to this, especially when we have this kind of stepped slopes. Another equipment used to investigate this kind of road is the side scanner radar. Then the information about the side scanner radar and the bathymetric investigation are complementary, and it's necessary to use a kind of corridor. There is some regulation, there are some recommendation related to the width of this corridor to get the information of not only the exact point when we intend to put the cable, but also in the neighbor region. Depends on the results that we have in bathymetric and side scan sonar. Could be important to use ROV, a remotely operated vehicles, that is the same vehicle, it's similar, the same vehicle used in petroleum industry. It's a vehicle that could go near some area that we need some activity need to be done, and they have mechanical arms, and they have cameras, and could see what is happening there and do some things. In this case, could be especially used to get samples of some rocks or some points that the people are intend to anchor the cable, to put some protection. It's necessary not to see, but to get some samples to analyze. If we are dealing with very shallow water, a diver inspection could be enough. It could be also more cost effective. Considering the possibility of burying the cable in the sea bed, it's very important to have samples of this. And normally these samples are analyzed in a lot of aspects that could affect the burial of the cable. To determine if it's possible or not, it's necessary to know the bulk density, the water content of the stones or the soil, some mechanical information about the material that we have found in that seabed, to judge if this slope, when the cable is passing, if its slope is stable or not, and to evaluate a kind of protection or burial feasibility that could be used. Any doubts about these two steps? Some people of South Africa and also some Angola discussed it sometimes with Brazil to put submarine cable just between Africa and there is some joint effort to combine commercial use with economical and educational use to have this, because when you look at the global map, most of submarine cable are in North Hemisphere, and now we are starting to have a lot here. Then The third step is the route planning. Considering the result of this desktop study and also the electronic route survey, the idea is to finalize a cable route planning, establish the route that the cable effectively will use to be installed. Before the manufacture and installation of the cable, people generally put all this information, what they call SLD. It's a straight line diagram that contains all the extension of the cable. In each part or section of the cable, what will be the protection the cable will have, and also what we call waypoints, some specific position that will be used as a reference. And we have a straight line diagram, straight line representation of the cable that is intended. It's a reference for everyone. Then the manufacturer needs to manufacture the cable considering this one, and it's looking at the first sight seems not be so difficult, but considering you need to use all the information in the deepness of the sea just to put this correct relation between the cable length and the position the cable needs to reach. Considering the vessels used for this, there are two kinds of vessels. The first one is the survey vessels. This is normally required for long or complex routes. In protected waters is enough to have a small vessel, and could be also an adapted vessel, but when you need to do a survey in long distance, especially involving points between island or continents, long distance island or continent, is necessary to use a special design vessel.
Route planning. I want to know what application you can use to know the line diagram. Application. Do you have one application, or I don't know?
Okay, it's what's the intended use for this representation? Okay, the idea, the first importance of this straight line diagram is to establish what will be the section of each section of the cable, considering the length and considering the protection. Why? Because this kind of cable, they need to be built completely at the manufacturer. When you install common optical fiber, we just have the fiber in the reel, we put and do the splice later. This kind of cable is different. The cable needs to be put inside the second kind of vessel, that's the vessel that will lay down the cable, in one, two, or a few parts. Then it's normally to have 500 kilometers, 300 kilometers, with all the splice in this right position. If there is any branching unit that could split the cable, it's necessary to be installed. And it's very important to consider the deep of the sea to know what will be the length of the cable, and considering the kind of seabed soil to choose, or activity to choose the protection of the cable. Then we can have, for example, 40, 50 kilometers from the beginning with double armor, well protected. Then we can have some kilometers, less than 100 always, with another protection. And we reach the deep sea, this lightweight protection of the cable. And to manufacture and the right length to put and all the splices box, to put all the repeaters, okay? It's necessary to have a complete information. Then it's an interactive operation between the information of we have in distance, in situation, in optical equipment necessity, to put all things there. It's almost the plant of the big plan of the cable. That will be the cable. 50 kilometer, one splice box, double armored, and after we have 100 kilometer of single armored, another splice blocks or several splice blocks in these boxes in this way, and after that 250 kilometers of light wave cable, and that will be manufactured and tested at the cable manufacturer and put in the ship this way to be laid down, as we'll see more in detail, that everything starts with this general view of the cable. That will be the cable. As we have a lot of information to get at that point, it's easier to put just some basic information. The number of sections, the length, the kind of protection, the position where we have a splice box or repeaters. Then considering this, we have since the first point to the last point, all the information necessary to build the cable. Why it's so important. When we consider a survey, the season is also the great importance. Of course, we are in a hurricane season. It's a big problem to lay down the cable or to get information. Then it's necessary to know about the season, because we are doing study with ship, with a lot of people, and season could in some place in the world play important some part of this information. Need to decide what and when to do. This survey vessel, in general, when the survey requires more than a day in open water, more requirements are usually necessary for survey vessel. Rooms for equipment, adequate working space, communication facility, good power supply, etc. If we have some distance around 700, 1,000 kilometers, that's not so difficult in this kind of application. This survey could take around 15 to 30 days. Most of the time, there are some people related to the information they are collected. As we have bathymetry, we have the sonar. We need people to do this kind of job. The people that use the ROV, but it's usually also to have in this survey people related to the cable project, people related to the buyers too, because it's a way to know more about. Most of the time, the buyers will operate this cable. Then it's part of the way to get information. This is a big ship normally when it's involved. This kind. Another kind of ship, the second kind used, as we call lay vessel. Then this ship will be responsible for put the cable in the right position, and there are some important parameters to be considered. First is that the people involved with this operation needs to handle the cable according with the cable specification. Most of the time, there are cables manufacturer representative inside this till the end of operation. The second important parameters is precise navigation equipment, normally differential GPS, because it's as we have all this information at the straight line diagram is necessary to follow, because they put in different position could cause some problems. And it's very important to be specialized people, to have a professional manning of these things. This is a general view, and when you look here, we have tanks, okay? And normally the cable goes in this way, and it's spoiling in this tank. Each of tank, it's possible to put around 600,000 kilometers, 600 kilometers here, and a cable with this two-tank model we can put around 1,200 kilometers inside of this. Then the boat needs to have an equipment to pull down the cable. Normally, is a caterpillar that's in that point, and the cable is carefully put with a speed of 5 kilometers an hour, around that, and the cable is manually arranged in these tanks in successive layer and fill the tank. When arrives a splice box, generally there is some position in the deck to put the box, fix it in a wood or some kind of device to keep the box in there. The cable continues to put in there till the time all the cable is here. After that, they have some equipment that's called the plug in the end of the cable, and after that we can move the ship to the right position and start from some point final of the cable, start to lay in the cable. There are some details I will discuss later in this presentation, but there are some different ways to do this in shore part and in the sea level part, deep sea part. There are some recommendations specifically related to this subject, and ITU has some effort in this, considering since the practice to install the cable to recommendation for the database containing all the information. After put all the cable in the ship, the cable installation should follow the procedures in order to guarantee the lifetime performance. And since in this case that's a more complex operation, there are a lot of things that needs to be taken into consideration. The first I described a little before. It's manufactured generally in a cable plant that's close to the beach, and around 200 to 700 meters from some position that could be reached by the vessel in case of submarine cable. In case of Marineised, it could be transported some kind of terrestrial transportation. In case of submarine, it's necessary to use that kind of special ship. For seagoing vessels, before the landing, the whole cable, length of cable of Marineised or repeaterless submarines cables to be laid is joined in order to cover the total link length. For the repeated submarine cable, the single elementary factor lengths are prepared in the factor. Then, when we have Marineised that's less than 300 kilometers, we just put in one section. When we have cables of more than that, it's better to split and prepare different sections, 2, 3, 4 sections, around 300 to 500 kilometers each section. And when I call section, is cable with that detail of different protection, the splice box and the repeater in case of the submarine repeater system. Then it's removed from the factory, almost done. The cable usually is stored in coils, like I showed before, in what they call sometimes pay-off tanks or turntable. It's transferred aboard to the vessel by means of special design path passing through crane wheels and a pier and special driving rollers. Normally, we have the cable manufacturing installation, and it's generally near the ocean, but there are other kind of houses and buildings, and then some has some tunnel, and the tunnel has a system that we can hang the cable and slowly move the cable to the position at the ship. During loading, it's very important to control some parameters, like attenuation and ohmic continuity, if applicable, pulling load, etc. The cable is then stored in coils in the tanks of vessel with cable ends available for testing. It's normally to have the traceability of the process, that each part of the cable is tested during manufacturing. Then there are some final acceptance of the cable inside the manufacturing site. And after putting this in the ship, the tests are done again. During all the way to the position where the cable will be applied, the cable is used to still energized, and there are some tests like questions to the repeaters. Show what is doing, and the same tests are realized before laying and after the laying, because of the need of specialized people. Sometimes there are different companies involved in this. Then it's not so difficult to have a cable that's manufactured under the responsibility of some cable manufacturer. And after that, the other company has the ship. Then in this time, the responsibilities of the company that have the ships. And there are some companies that prefer to participate of the laying. Then it's important to keep track of all this measurement all the time and to have a register. They took attention for some details, like they used to use an accelerometer just to see during these steps how was the force applied to the cable. They transform it in G, and in case of, don't worry, he's trying to get your attention. Must be some. It's okay. No. Then it's a very complex operation. It needs well control all the time. Then just final remarks before we stop a little to our breakfast. Care must be taken when storing the cable in tanks in order to avoid uncoiling condition, kinks, etc. And it's why normally people that put the cable in the tank or on turnable table is a lot of people working and carefully looking to the cable. During this loading, countermeasures should be available along the cable gangway, and both from the factory and from the vessel, in order to monitor the length of the cable and the closer position, if you want any, along the cable section. Then it's the first time outside the manufacturer that the condition of the straight line diagram are proved. Until that moment, the cable was in the manufacturer, and they were trying to do. But now, when we start putting in the vessel, it's very important to assure that all this distance, this length, and the position are according to the project. Any question till now? If not, I think we can stop for a coffee break. What's the normal time used for? Half an hour? Okay, then we can go back here, 4 p.m. Thank you. This is a representation of the situation we can find. Each section could include a large amount of splice box or repeaters. Generally, each section, the length of each section is around 400 kilometers to 500 kilometers, and is what we have in one of that coil we have seen before in the ship. This system should be tested during the laying and at the end of the laying to ensure that no significant system degradation has been induced. Laying testing includes transmission and functional test, and link may be powered. In most of these cases, we have power supply in both ends of the cable. That means that all the power supply for all the repeaters comes from one of the ends. If the cable is a short cable, generally they put power supply in both sides, one in use, another as a redundancy. And it's important to know that when the cable was loaded and after delaying, the characteristic, the optical characteristic, the functional characteristics of the repeaters, and also the electrical parameters are the way we expected. One important point is the shore end operation. In this case, we deal with the first cable portion that's installed close to the coast. And this laying activity must ensure that for the foreseen reliability and the life of the link. Usually, in repeaterless system, the shore end is not separated for the main laying in order to avoid the call initial or final splice operation. It means that if all the cable since the point that we'll have at the terminal equipment, it's included in that portion that we put in the ship, and that end of the cable will put in the land and reach the station. If the station is not so near the sea shore, sometimes it's necessary to have a terrestrial cable to reach some point when it will be spliced with this submarine cable. It's essentially, this kind of choice depends on the distance the optical equipment will be installed in land. The vessel is positioned on a foreseen cable route by means of a previously calibrated radio positioning system. and the cable is drawn out of the vessel by a service boat or floated, and is floating by means of balloons. The idea is to get the end of the cable, to bring to the beach, and put the cable suspended by balloons. Then it will allow to correct the position of the cable and put all the things in the right position before the removal of the balloons. When we remove these balloons are floating in the water. They are attaching one another, and the cable is suspended by this. When we remove the cable of the balloons, the cable goes down to the level of the shore, and depends on the case, is positioned in special position using divers or some help. Then we have the beach manhole, the end of the cable in beach manhole, or sometimes this station, if this station is near this position. In some specific submarine cables, people used to build fancy buildings to show the place where the submarine gets in the coast. And in some, it's almost funny, because when you look at the Latin continent, there are some specific place that's better to reach with the submarine cable. And there's different companies, they prefer to put this building just near the beach, and it's easier to get inside the building with the cable. And they used to build one building more beautiful than the other, just to make an attraction. Then in this case, it's easy to just put the end of the cable in the station. Then, as soon the cable is set in the correct landing route, the balloons will be taken off by the divers between the vessel and the beach, and there is a way to protect the cable by means of burial or articulated pipe, is depending on the case. Most of the time, it's necessary to have an extra external protection in this part. The idea is to have extra protection till the cable could be safely buried. After the completion of this shore operation, then the main laying, that means the lay that will use the ship, will start. It's why they separate this shore and the operation, because there's a lot of detail that must be taken into account, and it's separated for this reason. After that first part, we start with the sea lay operation, and lay is normally undertaken only when weather or sea conditions are not the ones that could create severe risk of damage to the submarine portion, or the cable ship, or the lay equipment, or even the personnel. Then why it's so important to study the season in the effect in this region in the study I have mentioned before. During laying, all appropriate measurements should be taken to control the vessel route using the GPS, different GPS, using the speed and laying slack together with the pulling tension applied to the cable. During the landing, sometimes an actual sounder is used in order to compare the data related to the structure of the seabed and with the comparison of the data we get in the survey. With such elements as especially the slope, the slack, and the vessel speed, it's possible to adjust the condition if necessary to have a perfect laying. At a constant vessel speed, then the cable is laid in a straight line, and the slope depends on the cable type, especially how heavy is the cable, and the vessel speed. The recommendation is to adapt the speed to the seabed profile. In this way, the slope must never be less than that of the bottom. Then we have some movement of the cable, the slope of the cable. It's better to have this slope almost similar to we have in the bottom of the sea. Otherwise, suspension and risk of faults could occur. Then all adjustments are made to correlate these three parameters to assure a good laying condition. Usually, armored cable are laid on a speed of 2 to 3 knots. Each knot means around 1.8 kilometers an hour. And in some cases, it's necessary to reduce the speed due to particular bottom condition. The idea is always take care with the risk of kink formation that could damage the position of the cable or could also damage the cable. During the laying, this slack parameter is under appropriate control in order to allow the cable to recover the bottom, to cover the bottom irregularity. This parameter, this slack, is the percentage of excess cable length laid with respect to geographical distance covered by vessel. Then we have a linear distance covered by the vessel, and we have a different distance that the cable will necessarily to be applied in the bottom of the ocean. Then it's important to use the information, all the information we get before to reach this a good point to allow that the cable that's laid down just goes to the end, to the bottom of the sea in a good condition. And this perfect condition to allow the cable to be put in the right position in the ocean is important also to recover the cable for maintenance purpose. And the idea is to have the speed of the vessel, the speed of the cable is laying. There's a relation between the two to consider the profile of the sea bottom and to allow the cable goes down in the position planned. As we move to lakes and river, I'd like to ask you if is there anything we can detail more till now. Any question, any doubts about this part till now? Yes, sir.
In 1.11.3.1, there is a diagram showing a repeater in underwater. I'd like to know how is this repeater powered. I'm talking about cable loading, and I'm talking about as well figure number 3-14. Yeah, I'd like to know how the repeater powered. Is it powered or it's a passive equipment?
No, it's our powered. It's powered from the station of one side. the general, if you have a cable of, okay, and the splice box are passive, and the repeater needs electrical power. And then the idea is to have part of the cable with a metallic sheet that transmit all the power, electrical power necessary to all the repeaters. And take the example, and we have 500 kilometers of cable. The good practice is to have all the power feed equipment in one side, and there are special equipment for this. It's one of the important part of the submarine system that could send the power for all the repeaters. And most of the time, they are the opposite side. We have another redundant equipment ready to put online if necessary. Then when you look for this, we need to think about the cable. But there are some blocks that are constructive blocks that are important. Then we have the cable. The cable is, the termination of the cable is in the PFE, the power feed equipment. It's a big one, and it's earthed and it's connected with all the electrical part. Then the optical part goes to what we call system line equipment termination, and after that we have the SDH or so that used to transmit. Then when we plan to install a cable like this, we need to care about the cable and the optical transmission. We need to care about the electrical power feed. We need to care about the termination, the optical termination equipment, and after that, what do with the communication we have inside the cable. That's it. Most of the time, this is built, and the main manufacturer of